So, hello everybody. My name is Mahendra Baragi. I'm machine learning solutions architect at AWS, and I have my colleague Shreyas with me. And you see my screen that shows the presentation, okay, and not the video.
Yep.
Okay,
Yes.
awesome,
Yep.
nice. Uh, so it's our pleasure to cover this topic, industrial use cases for machine learning. So me and Shreyas will go through some of the use cases. I will walk through some code as well. If you have some questions on the code, please let me know. I've been with the AWS 5.5 years now, and I've been here mostly as a machine learning solutions architect. Worked with more than 200 customers so far. So whatever use cases I'm going to present to you today, they are the one that I or my colleagues worked on. Mostly I did it, um, and then and I believe most of these use cases are public as well. Then I came to MIT once at least, presented at MIT conference. Bruce invited me. Um, I have done multiple workshops. I also presented at Carnegie, and I'm the guest faculty at Arizona State University, and I'm also a capstone guide. So I will actually talk about that project as well if I get chance today. So um, with the machine learning, last 4 or 5 years, things been really crazy for me especially. I've been traveling all the time, going to all these customers. Same with Shears, my colleague here. And then you might have heard about this course. I'm just going to go through in 1 minute. So IDC says that uh, $50 billion spend on the AI/ML. I think it's more than that. Okay, I've been to multiple customers in person, and I think it's 50 billion in just the auto, I can think. Okay, and then the COVID just accelerated this, so there is a lot more use. There is a lot more spending in AI/ML, and then lot more organizations are getting into AI/ML. This last number, the 5.8 trillion, is the potential across 19 industries. Okay, I think there are more industries. I don't know why they said 19, but let's look into some of these industries really quick. So I have uh, I have an 18-year-old son. So 4 or 5 years ago, he wanted to start driving, and then he is like, "Hey, Dad, can I learn the driving?" And I was, and as the technical dad and very cautious dad, I was like, well, I should probably tell him the different types of distractions first. So I wrote this app, and then I uh, got this app together. Let me show you the app really quick. And let me know if you see my app, the screenshot of the app. If you don't,
Yes,
please
we
let
can
me
see
know.
it.
Yeah.
We can
So
see
you
it.
can see my son is trying to, and the car is not moving. So I just have app on on the passenger side, and then he is looking at me, and you can see the different types of distraction. So I developed this 4 or 5 years ago, uh, and then you can see the different. He's looking at the phone, trying to talk to passenger, and then there is one here, a very important one, where texting and talking to passenger, which is not allowed. So when the phone screen is not pointing to camera, it doesn't know if it's a camera. It's a phone, but when the phone screen is pointing to camera, it knows that is phone, and now it's texting. So this was really good. My son hates this app, but I think I was able to tell him there are. I found out there are 10 different types of distractions. So there is I was able to identify a lot of these distractions, and he now knows a little bit. But the good thing about this demo was I presented this demo at CES a couple times, and then it evolved, and now we include this demo at a bigger prototype called as Future of Mobility. So now we have done Alexa integration. uh, I know a lot of you already know data science. So I developed this demo 4 or 5 years ago. I used the object detection, the image classification. If I do it again, I will probably not do that. I will probably use something else, mostly the segmentation or something. And then over the period of time, we uncovered some legal problems with distracted driving. So I will not go with that kind of distracted driving. I will probably go with the gaze detection. Yeah, so now I'm doing more of a gaze detection in my the demo, which works okay. Then uh, you might have seen, well, there was one media company, and they reached out to us 4 years ago, and they said, is there any way they can look at all the brands and logos in their content? So if you notice, a lot of these media people, they have these videos, and they just go and do shootings of these videos, and then inadvertently they are showing the logos of many companies, and there are legal issues as well as it's a revenue stream for them. So they can charge these brands, and then they can get some the money or new revenue stream. So I was able to do that. So there is a demo there as well. And then what we have done, and if you can, if you want, you can just copy this the URL. So this GitHub here, that also evolved now. So now this, with this GitHub, you can actually go to you can just input the media, and you can get the content out saying that what this media is. And not just video, it also does the audio analysis, so you can get the translations, or if you want to know some insights on the data, like what kind of a sentiments, so you can do that too. So all the code is available here. Then then there was another company, they agriculture. Okay, I never thought that there is going to be agriculture use case in machine learning 4 or 5 years ago. And they said, hey, can you help us out with this drone footage, and we want to see if we can count cows. So they want to count the cattle in a drone footage. Well, I was trying to do it real time on the drone itself. It didn't work. So we are downloading the drone footage on server, on cloud, and then doing this analysis. So this was done 3 years ago. If there is way, with the NVIDIA, the Watt talked about their devices, I think there is way now you can do this on a drone itself too. Yeah. So um, if I get chance to do this thing again, I will probably put the model on the drone now. Yeah. So this is totally possible. So this is accounting the cows, very simple, the object detection model, looking for certain objects and counting those. So this is something that I have done some time ago. um, so these are some use cases. And then the oil and gas, there is a company in a uh, I had to go to Alaska for this. So they have whenever there is a flare detected in their oil and gas. So this is a public demo I actually did, and I presented at. Uh, it's going to open the YouTube. Okay, do you see this? So this is, and I have code available for this one. If anybody interested, let me know. So they wanted to know, whenever there is a flare detected, what happens is there is a regulatory pressure. So all the use cases I talked about, there is a revenue stream, or at least regulatory pressure. So there is something going on. So these are real use cases. So they wanted to know, if there is a flare, then they want to detect it and then notify. So the flares, they are kind of a environmental problem. Not just that, they also, right now is manual, so somebody has to sit there and and monitor it. But whenever there is a flare, it means you're wasting the precious natural resource, and also causing problem to the nature. So now there are different kinds of uh, fundings available in these big oil companies to look into these use cases. So this use case is something not revenue generated, but I noticed that there is going to be a lot more funding for this kind of use cases. So all I did was the object detection algorithm. If I get chance, I will probably do something else now. I will probably do semantic segmentation for this one, but the object detection works. Yeah, but this works in most cases. But if you go to Alaska, there are certain situations where it may not work, like there is a snowing or something. Then you gotta have more images and you train the data, the better, and then it works. But this project is implemented already. Then let me go back to my slides. So the use cases I talked about on this left side, I worked with NVIDIA all the time, me and shares both. So a lot of our model training is done using NVIDIA GPUs. We also implemented robotics using some of the NVIDIA end products, or the uh, end hardware, like the Nano, the chipset that Watt talked about. So these use cases are very simple computer, the vision type use cases, and then they follow very similar pattern: the image classification, object detection, the semantic segmentation. There is a lot more going on in this area, obviously. Yeah, and then the recently, uh, there is a lot more going on in the NLP, as well as the time series data. So when I was looking at there was when I was looking at the COVID kind of a use cases, so there was a thought process in our company: why not we come up with some kind of a intelligent search based on for this COVID data? So Shreyas was on that team. So he and his colleagues, they developed this, the search engine. So the difference between, let's say, keyword type search, like what the Google uses, the in that search you are just giving the keywords. In the context based search, or the intelligence search like this, you are giving the contextual data. So you are asking the question. So like, what are COVID symptoms? um, or what is the rate of infection, something like that. So you can ask the actual question, and you can get the really good value out of it. So we've been working with MIT on this one too. But this website gives really good idea what the contextual search is. And this, you can see that once you uh, ask the question, you also have say whether this is the right or not, this is the right data you're looking for, or the search you're looking for, or not. And you can have influence on the search. So you can send this feedback back to the search, and the search will improve over the period of time. So this is a really good idea. um, Behind the scene there is AI, the NLP, as well as there is a keyword type search. So combining these two things together, we came up with this idea. And the technology behind it is what we call is a Kendra. So Kendra is our intelligent search, the service. Then I will show you the code for this one. So for recently, uh, the industries, the manufacturing and logistics, they were a little bit behind in machine learning, because a lot of their data is time series. And then the time series search was, it was there, but not as the cool thing to do. But now last 3-4 years, we've been seeing a lot more value in doing the forecasting and anomaly detection. So they wanted me to build some the prototype for solar power production. The one of the biggest thing about the data science is you got to have the data that you own, or it has to be open source for public projects. You cannot use those for commercial projects. At AWS, our work is considered as commercial, so we cannot use a lot of open source data sets unless it's for prototyping or something like that. So for solar power production, I use my own data. So let me show you what I did. So I have solar panels. I live in Arizona, so the solar panel makes total sense. But if you look at the data in a solar panel, you will see that it has the sine wave. So in summer it goes up, in winter it goes down. And then you probably see there is some anomaly already. This is where the system was down. So there was some connectivity issue, and then I didn't have data for it. So you can see the actual sine wave. So all I'm using here is just a simple notebook, the Jupyter notebook. Then I imported my data. And then you're probably familiar with the LSTM algorithm. So I used LSTM algorithm in this use case. And then LSTM works very well for the time series data set, especially if it's the single time series or very simple time series. The difference between LSTM, so you may see the similar patterns in the stock market, but you cannot really use this kind of algorithm to predict stocks. Stocks are based on the leading indicators, not lagging indicators. The lot of forecasting and prediction is based on the lagging indicators, just to find the patterns too. So we are using LSTM to find this pattern. And then I imported it. in that notebook. And then this is supervised learning. So I had to split the data 70/30 in this case. And once I split the data, I trained the model, and now I'm doing the prediction. I'm just going a little bit fast because I want to give some time to Shreyas as well. And then see here. So this is the actual prediction, the green line, and the red line the is a ground truth, the actual data. So with just a simple LSTM, I was able to do prediction, very well prediction of the solar panel output. And then you might have seen little spikes here and there. See, the solar panel production is not just dependent on the solar or how the solar, how good the exposure to the sun is. It also depends on the weather, and it also depends on your instrument itself. If I input the weather data here, then whatever anomaly is left is most likely going to be the instrument. So by using this forecasting, I can easily switch this forecasting to anomaly detection. So for example, here, if this was the weather issue, so there was something wrong, the cloud coverage or rain. So if it was not like this, so you can see this one here. So in prediction, it will definitely show this as anomaly. So you can actually use this kind of algorithms for anomaly detection. Then this is simple time series, but if you look at the time series data, there are multiple time series, many times. So this is just one solar panel. What if I was in a solar farm and there were many solar panels, different locations? Then this prediction may not work. In that case, I have to go with some different mechanism, and that's where uh, we also have, that's where you don't know if you want to use one algorithm or you want to use multiple different algorithms and run these experiments. So we have a service called as the forecast. So what we are doing with the forecast is you can run your data set, and then it will do auto ML. So it will give you it will run your data set through multiple different the models, and then it will show you which model makes sense. So in my case, so I used the solar data, then that I imported that data. Behind the scene, the algorithms are pretty simple. Well-known algorithms. So it can be ARIMA based algorithm, or it can be the deep AR. I don't know if you have heard about deep AR, but deep AR is really good for multiple time series. And then it's based on LSTM as well, or RNN. So I ran the same data set, yeah, uh, through the forecast. In the forecast, it is going to run it through multiple algorithms, and it ran through multiple algorithms, and it said that the winning algorithm was DPAR plus. Or DPAR is LSTM. We don't have LSTM as an independent algorithm here, but we have DPAR plus. So the DPAR, this system told me that the DPR is the right one. And then after I ran this through this, I created the forecast, and the forecast looks like this. So solar, and I just gave the data, what data I'm looking for a forecast, and then my forecast key, which is a solar panel. In my case, is just one because I have just one set of solar panel, and I don't have solar farm. If I had a solar farm, I would have had multiple time series and multiple key IDs. So if I do the forecast in here, now you can see. And the good thing about this one is in many forecasting algorithms, you need p values like p10, p50, p90, p99. That's the probability values. So this probability, now you can see the better forecast. Yeah. So um, now there are many of our customers are now using the time series for forecasting too, and we have multiple tool sets for forecasting. If you ever want me to, if you have any questions on this one, please let me know. And then and we'll have some time for uh, the code walkthrough and questions too. So it, when it comes to the
So yeah,
logistics, yeah,
we're I think like maybe 2:30.
okay,
Just want to make sure Shiraz has time to
yeah.
talk
So
about
now I will
his
give,
topic.
yeah. Now I'm going to hand it over to
Okay, great.
my colleague. Yeah. So so when it comes to robotics automation, we live and breathe robotics automation. That's what we've been doing. So we develop multiple the solutions and in our the stack. So Shreyas will go through those now. Shreyas, you want to take over the screen?
Thanks, Mahendra, for sharing my
Thank
screen.
you, Mahendra. That was perfect. Sorry, we got you guys started a little bit late, and
No problem at all.
we have some extra time in the next lab, so we can definitely run a little long.
Hopefully, you can see my presentation here.
Yes.
But I wanted to connect, what we saw with Mahendra's talk, and I caught the last
Yeah,
part
do
of.
you want to introduce yourself a little bit first, and
Yeah, sorry, I
so
didn't
that
do introduction for you, Shreyas. You can go ahead.
and also just so people know that in addition to solutions architects, that AWS is now bringing in data scientists and kind of expanding their breadth of capability. So I'm sorry, go ahead.
Thanks, Bruce. So my name is Shreyas Subramanian. I'm a machine learning specialist, and I work with Mahindra. Like Bruce was saying, within AWS we have a couple of different personas that talk about machine learning. There are the solutions architects, and to I think Ward's point earlier, where you need to productionize your machine learning applications. That's where solutions architects can help. And some of the more deeper applications of actual data science work, there are roles within AWS for both internships as well as full-time positions for data scientists that can help customers do their end-to-end machine learning. What I wanted to focus on in the next maybe 10 minutes or so was a specific application of visual quality detection and anomaly detection, and with the context of the automotive industry, right? We saw a lot of really great examples from Mahindra, and he touched on a few services that are managed AWS services that can help you and help customers basically accelerate progress towards a good model, right? Whether that's for forecasting or computer vision based applications. The one we're going to look at today is specifically to do with anomaly detection in visual data, and how it can be applied to industrial applications, specifically in automotive, right? We have tens of thousands of customers using machine learning on AWS, and they have a wealth of data, right? And all these industrial customers, they have all of this data, but they struggle to find value in it. One of the key kind of applications is, warranty cost, quality assurance, and anomaly detection at the edge with visual inspection, right? So you see on the right there, you see a typical operator going in, or a service person going in and checking some components visually. We saw in the diaper example as well earlier, where you had a camera set up, and you have to actually do this at a rate that's really quick for a human operator to do. So computer vision is used currently in lots of customer applications where they're using this to detect scratches, defects, spots, dents, and these kind of things in typical manufactured components. The value to the industry is actually billions of dollars every year. So imagine an application that looks at defects in spools that are made to used to manufacture seat belts and airbags, right? It's not just the cost of producing that application, it's also the cost of, if you produce a defective application, that particular customer is also exposed to liabilities and lawsuits, so you're kind of protecting them at that level. So broadly, today's challenges are, one, it's really difficult to get set up your manufacturing lines in such a way that it's collecting information, it's collecting data, it's collecting related information like vibration, temperature, and all of that. And where do you store that information, right? That's the first kind of challenge. The second one is, now that you have all this data, how can you train appropriate models and then run these models to predict these defects and other anomalies? And the third one is, how can you keep improving this? And where AWS comes in is, we just like the forecast example and the other examples like Kendra for the intelligent search that Mahindra was showing, we package these services that behind the scenes run state-of-the-art models and algorithms and make that entire journey for the customer much simpler, right? So this is a lot of services. What we're going to look at is just one of these services. So up on the top left here is Lookout for Vision. But Mahendra also mentioned a couple of these. We can come back and then look at some of these and the applications specific to these. But Lookout for Vision, the goal is to spot defects, right? So that's what it's doing. It's doing that using computer vision, and the goal is to automate quality inspection, right? So simple problem statement. Uh, and the way you do it within the AWS console is, let's say you have a bunch of images that are collected, you pull it up in a data store called S3, a simple storage service. You connect that to Lookout for Vision, which will actually train a multiple sets of models, and it'll give you the best one, just like in the forecast case where we saw DPR. Here it's specific to a state-of-the-art visual anomaly detection models. And then you can provide feedback, right? So as you get model metrics and scores and you apply it to your test sets, you can provide feedback so that your specific model improves. Your data is not used elsewhere, so it's secure. It's only used for your application, and your model is completely yours to use. Here are a couple of visual examples, right? So in the left here, you see like a surface defect on a PCB or a printed circuit board, where you see a scratch up there, and that's actually the example we'll be demoing. In the middle, you have like a door panel that's also scratched, and you want to detect that at a service center or a shop. And then it's not just about scratches on surfaces. It's also about missing components, right? So, for example, you're processing multiple PCB boards per second, and you want to identify ones that don't have proper solder or don't have a particular component, or have a component but that particular component is bent or has a defect. So those are all use cases that Lookout for Vision, which is the service for visual anomaly detection, helps with. Um, like I said, it's not just for automotive and the high tech electronic industry. On the right, you also see like an absence presence test for a pill pack or a blister pack. So it should be able to detect, with the variety of colors and patterns of the background and the foreground and the color of the pill. It should still be able to detect which ones are which strips are defective as a whole. So I just want to paint this picture of a manufacturing line in the automotive industry. On the top left here, you see that there's a camera installed that looks at the plain sheets of, for example, alloy and metal that will be rolled up and stamped, right? So every step along the way, you have inspection during the rolling process, inspection during the stamping process, and then you're looking at welding defects and welding quality, and then even after your entire part or components have been manufactured in your assembly line, you also have to look at whether these parts are placed in the right position and configuration. And then after all of that, before you go get into the paint shop and your chassis is ready, but you need to apply paint. You want to see if it's uniform. You want to see if there are any defects or smoothing errors, and then the final inspection before you actually deliver your product out. In this case, a car. So all of those steps along the way is where not just Lookout for Vision, but multiple other products and services within AWS can help. Usually, it's not about one service; it's about creating a solution. I'll show you how a couple of services can interact in a demo. But with that, let me just switch out to showing you what it looks like on the AWS console, right? So once you log in, you search for Lookout for Vision. You should get in here and very briefly imagine that we've already added the data set. That's the simple part, and you've hit train and it trains a model, right? So let's look at one of these images here where you see of course, there's an obvious scratch, The pins are slightly bent, and there's some solder quality issues as well. So just wanted to point out that this has multiple defect modes. We're not looking for a specific defect, which may or may not work for some use cases. Many customers will say, "Hey, I don't care if there's a slight angle to the pins. I just want to know if there are scratches on my main PCB board, or if a component is shorted, for example." Um, so lookout for vision can be one component that solves the entire problem. It's likely that you will use others. And I really like the discussion about eigenframes within video processing as well. So we did have a recent use case with a manufacturing customer, and actually also an automotive customer, where they have a real time video coming in, and you need to analyze the video for defects. It's not specifically just for an image, which in this case for lookout vision it is. So it's really easy to both add labels. So you see some of these are marked as anomalies, and others are marked as normal. So you have 50 normal images and 44 anomalous images here. So it's easy to go and hit train model. I'm not going to do that now because I did that right before coming in. So I've trained two models. It gives you like high-level metrics like precision and recall. Again, like in the forecast case, it trains multiple models in the backend and shows you which one has the highest, for example, overall recall. So as you can see here, one of these models is hosted, and the other one is the training is complete, but it's not hosted. So the hosted model basically is where you can treat this as an API call. You can send in an image and then get back a response. And I have a script here that's sending in a image that's either a normal image or an anomalous image at random. It's sending it to that API endpoint every 5 seconds, and it's coming back with this JSON response. So this is very typical of many AWS services where you're sending in some payload, whether it's an image or a set of uh, time series data points, and getting back a JSON response. But what you do with that JSON response is up to you, and there are many other integrations, right? So you can take that JSON response and this confidence score and decide on whether you want to act on it by connecting to a PLC controller on your production line. But the easiest thing in terms of integration as well is you have metrics that are usually for all of these different services. You have metrics in this case where we're counting the detected anomaly count up for every 1 minute portion of time, and summing that up, right? So and we want to check if it's above a threshold level and notify an operator, right? So this is an example of like a nice integration between multiple services where here we're using CloudWatch to create an alarm that will send a notification to a set of interested parties. And so, like I said, it's always about building a solution, and it's not just one service. With that, I'll stop talking about this particular application, and maybe we have a couple.
Yeah. Well, I was going to say, could you just talk a little bit about Monotron, because that fits very well with the use case we've been studying. So we've been training models to detect anomalies in hard drive data. So, temperature, error rate, read-write error rate, read-write rate. And so we've got all these different continuous variables coming in, and I think Monotron kind of approximates that in an industrial sense. But I thought this was kind of a groundbreaking announcement, because there's so many companies out there that actually do this separately, and for a cloud provider to reach all the way out, make a simple piece of hardware, and then the whole data pipeline behind it, it's really pretty groundbreaking. So if you could just talk about Lookout for Equipment and Monotron, that would be super.
Yeah, I think both of those are pretty relevant. Starting off with Monotron here, right now, a few customers are using this with, for example, you have a compressor, or you have like a wind turbine. These are large equipment that have typical signals that come out like vibration, temperature, and you want to use that and make use of the back end as well. So this is just the physical hardware that gets attached. So you have these sensors as well as a gateway that actually sends back the data and also caches some of it locally when there's low internet connectivity. So they've thought of all of these different aspects of where you don't necessarily have great internet out at a wind farm, and also the people who are operating these equipment also want to see the end result of it, which involves pre-processing data, having an entire ML pipeline, choosing between multiple anomaly models, and then providing you with a report at the end of it. So that entire pipeline from hardware to cloud software is provided through Monotron. And yeah, look out for um, equipment. Let me just bring it up so we have like a visual like reference. Um, but this, you know, this is related to anomaly detection with time series data, right? But it can be any equipment data. So usually, with as an example, with a compressor, you have like flow rates, you have pressure values, you have temperature, vibration values, you have noise values. So all of these are totally erratic signals. When you look at it on a plot, it looked far worse than what Mahendra was showing us with the solar values there in that example. It just looks like noise, right? So what Lookout for Equipment does is, again, it has a zoo of models that are trained to pre-process and then use the extremely noisy sensor data, and you can go up to hundreds of sensor values, and provide regions of high confidence where it thinks there are anomalous behavior. And this can be used for root cause analysis. This doesn't provide root cause analysis directly, but you can take that in a report and then use that as part of your RCA, and kind of tie down to what component within your entire um, subsystem is actually creating a problem, or ones that actually led to failure. And failure can be either like partial failure or complete failure of equipment. So all of that is still covered. So look out for equipment, look out for metrics, and look out for vision were kind of purpose built for industry use cases. So definitely do check that out, and we'll be happy to come back and kind of dive deep in a few of these areas as well.